Hello class, today we're going to learn about radian measure. Radian measure is a type of new unit that we're going to use for angles. So we're not going to use degrees anymore. And that is because it's helpful to talk about radians, which is a measurement that deals with circles. And we use that a lot in mathematics. And so it's important for you to know radians for future math that you're going to learn. So now we need to talk about where does radian measure come from. Well, first we need to understand what an arc length is. An arc length deals with a circle, and it comes from the idea that if you measure two lines from the center point of a circle, the arc length is the distance from one part of that angle to the other part of the angle. So it's just along the length. Okay, and so we can define it as the measure of the length of the curve formed by an angle. So the angle would be inside of this section of the circle. And if you think about it, that's basically one section of the whole circle, which we would call the circumference. And so now we can get into a closer idea of what a radian is. A radian is a unit of angle measurement whereby formed when the arc length is equal to the radius. So in this diagram here, this length formed by the radius is the same distance as the arc length being formed by the arm here. Okay, and so what is that approximately? If you have to go back to your degree mind, you can basically say that one rad or one radian measure is approximately 57 degrees. It's not an exact value, but if you had to gauge it from your old understanding, this is about 57 degrees. And you might wonder, what happens if I draw a smaller circle? Well, the smaller circle will have a shorter radius, and therefore its arc length will be also shorter. And so that rad is still 1 rad here, okay? Just depending on your circle. So if I draw a medium-sized circle here, again, it will have a different arc length, which is compared to its radius. But that would still be a radian in there. Okay, so if you think about it, well then, how does that work for a circle? In terms of how many radians are in a circle? Well, it turns out that if you have this radius here, then the 1 radian measure, or 1 rad here, will be here. 2 rads will be here. Here's 1 more rad. A 3rd rad would be here. Oops, sorry, 1 more rad here. And then it turns out, and my drawing is a little poor, but that it's really half a circle is 3 radians and 0.14 rads here. That sounds interesting. So in total, we have a half a circle that is about 3.14 rads. Think about that. Doesn't that sound familiar? Well, it turns out that 180 degrees is basically 3.14, which is your pi. So a half a circle is about 1 pi radian measure. And so we'll be using pi as a unit of number in radian measures. So then therefore, a full circle rotation will be 2 pi radians. Okay, and you can watch this animation here by clicking on this link. So how do I go back and forth using arc length and radians versus the radius? Well, this is all related by this formula here. The arc length is equal to the number of radians times the radius. Okay, and so I can use an example where if I want to measure a specific arc length, so for example here I have this line 1, 2. So here I have 2 radians, 1 radian, another radian. So if I have this as equal to 2 radians and my radius is r, So now that would be times r. My answer for my arc length here would be equal to 2r as my arc length, or 2 radians. In a unit circle, the arc length will simply equal number of radians because the radius is 1. So that's just something to keep in mind when we think about unit circles. How is this related to the circumference? Well, if you think about a circle with a radius r, the arc length for this will be equal to, again, the number of radians times the radius. And so the number of radians, well, if we go a full circle here, that is 2 pi, right? So we'd say 2 pi. And the radius is just r. Now that just simply becomes 2 pi r. Doesn't that sound familiar? That is exactly the formula for circumference. So this arc length equation for a circle makes sense, and it applies back to that circumference formula. And now you know where it comes from. Okay, so now how do we use this? How do we change our mind back and forth from degrees to radians? Well, let's take an example. If I have 120 degrees, then I need to change it into radian mode. Well, we know that the unit of conversion is that it takes about 1 pi radian is about 180 degrees. And so if I want to convert from degrees to radians, I simply multiply that degree by pi over 180 degrees. And so what happens in this example is that the degrees will cancel out. And so now I just do 120 times pi all over 180. That is simply now about approximately 120 pi over 180. And you simplify that to simply 2 pi over 3 radians. Okay? Or just rad for short. One thing to note is that when we talk about radian measure, we're always going to try to leave it as exact value. Okay? So because we're using pi as a unit measurement, we're not going to change it into decimal forms. We're going to always try to leave it in exact values. Okay? So leave the pi in there and leave them as fractions. Let's try another example. Well, now once we have our given radians, what happens if you want to go back to degrees? Well, so in this example, we have 2 pi over 5. And so the way to go back, so if degrees to radian was timesing it by pi over 180, now we have pi, we want to convert to degrees. We're going to go from radians to degrees. We are going to go and multiply it by 180, divide that by pi. Okay, and that will get us our degree mode back. So if we're going back to this example, times this by 180 degrees, divide by pi. By doing so, we're now going to be able to cancel out the pi because we don't normally see pi in degree mode, and that cancels using this formula. And we're going to multiply 2 by 180 and divide by 5, which is simply 72 degrees. But in this unit, please don't go and convert all radian measures to degrees in order to do the calculations. We're only going to do that when these questions ask you for it. So only convert to degrees when we're asking you in a question. Do not convert to degrees to solve everything. It'll just become too time consuming. Okay, now let's talk about how we can apply this now to a Cartesian plane. So what does radians look like, and how do we use them in, for example, a unit circle? So this question says, determine the coordinates of the point on the unit circle at 1 radian. So 1 radian is approximately 57 degrees, so somewhere like this. And it wants us to figure out the exact coordinate spot. Well, Therefore, we have to think about it in terms of our x and our y. And what are that exact values? So we want an x and a y coordinate. Well, we have a unit of measurement for the angles. We know that this angle is one radian, 1 rad. Okay, so we want to be able to kind of think about it as an angle. So we can still use the theta symbol for the angle. And so basically, to figure out the x value here, this side length here, that is the adjacent side if we know the angle. And this is a unit circle, so we know that the radius measurement is 1. So when we talk about an x value, it comes from looking at the cos of theta. Because if you remember, cos of theta is equal to the adjacent side, which is x, divided by the radius. And in this case, the radius is 1. So we can therefore just consider x over 1, which is simply just x, which is what we want in the coordinate. Okay, and then we can now similarly think about how we want the y measurement in order to figure out this. Basically, we want this length here in order to figure out where the coordinate of y is. And so that comes from the opposite side length of our angle of 1 rad. And we know that the radius again is 1. And so if we think back to the sine of theta is equal to y over r. And now in this case, it's y over 1 because it's a unit circle. So sine of x is just simply y. So we can just write sine of theta. And, well, in this case, when we're talking about radian measure, we said we want to find the coordinate of 1 radian. So therefore, we're really just looking for is the cos of 1. And we're looking for the sine of 1. But when we start punching this in the calculator, we're not talking about 1 degrees. So now we have to change your calculator into radian measure. How do we do this? Basically, on your calculator, you want to make sure that the top tiny little letter at the top is now R instead of degrees. And how do you get that? By pressing the mode button on your calculator a few times until you have the option to select the rad mode. Okay? And so when you type that in your calculator, cos of 1 ends up being approximately about 0.540, and the sine of 1 becomes 0.841. And so your coordinate for 1 radian is the measurement of 0.54, 0.841. So let's do quickly one challenge question and apply radian measure to it. So basically we have a monkey hanging from a 2-meter long vine. The angle to move from one branch to another is currently written as 50 degrees. What is the arc length is what we're after. So basically this distance here. And so arc length deals with radian measure, not degrees. So you want to be able to first convert this 50 degrees into radian measure. So we'll go 50 degrees times that by pi over 180. This now allows us to get rid of the degree mode. And so we go 50 times pi over 180, which simplifies to 5 pi over 18. And radian, or rads. Okay, so now an arc length, if you recall, an arc length equation was the number of radians times the radius. And so we have 5 pi over 18, and the radius they told us is 2 meters. And so our arc length will now be at 10 pi over 18, which actually simplifies to 5 pi over 9. And so we write a therefore statement that the monkey swing is 5 pi over 9 meters because we used 2 meters in length. Okay, and that is how we apply radian measure instead of degrees.